Let's start off with a little bit of a vloggy bit, and this is one thing that winds fitters up more than anything else, is taking more space up than anybody else, and this is what my toolboxes are doing at the moment. This is me, lost a lot of weight, and there's my old toolbox that was in the living room. I've brought it back and put it back in the workshop because of the lack of space. The crown jewels are in the top, readily accessible. Now this is me, lost a lot of weight on a ketogenic diet. Yep. There's a blog about it. So I've got a lot more space in this toolbox, and I can reach things without having to chuck things on top of each other. Okay. The only thing I don't like about these wide drawed boxes is the fact that the drawers do this. Okay, you can see that. Yeah, it's okay. However, it sometimes feels like the drawer's going to come out when you open it. However, the top box was second hand. Bought it at a steal. Really happy with that. And this little box here is going back home again. I think we'll have to do a series on how to build up a toolbox for DIYers at some point using this box. And also I've got a job of rebuilding this trailer tester for lights, and also for putting air pressure in at a regulated amount, and this is actually quite vital. You can see the adapters here. That's for checking with gauges the pressures. Okay, hello, welcome back guys and girls to the vehicle repair toolbox videos. However, we were Land Rover toolbox videos and we still seem to be covering Land Rovers at the moment. Right, so on the toolbox is a diagnostic tool, which is the Ethos Tech by Snap-on. This one is a very basic machine which will read fault codes, and it will also operate special functions. It's limited, but it is exactly powerful enough for a technician to do diagnostics. So what we have here is a Defender 2.2. It's a cherry picker. Yes, there's more than one in the fleet that we look after. So basically we're going to use Ethos Tech first of all, because when it was recovered back, the AA man said it had an electrical problem. So I'm looking for DTCs. So what we have here is the fuse box relays, and where the EOBD plug is on the Defender. As you can see here, the position is underneath the steering wheel. Most EOBD plugs are now somewhere near the steering wheel. First check is to see whether I have EOBD power, to see if it will power up the Ethos Tech, which it does. So we're all right there, and basically this will now just start up, and then it will ask me what vehicle or vehicle make I'll want to look at, and I'm saying Land Rover. Give it a year and it should do an automatic test. Okay, so we'll go for Land Rover wherever it is. Land Rover is there. Okay, and rather than going through the models, it just goes for the year, and this one hasn't actually. This has gone straight to automatic ID. So this will read the vehicle. Now the second thing is, can I actually read it? And this will be through the COM system, because the EOBD is connected to the CAN line, which communicates to all the different ECUs. Now this is actually quite vital. I'll explain this in a minute. So it's got the VIN number, so it's talking to it, and basically now I want to do a code scan. And that's what exactly it'll do. This does it with every vehicle. So the reports have got the vehicle recovered with reported electrical fault, or possibly brakes failed, and that's a question mark there, electrical and brakes. But the driver's report is grinding and clonking noises, then a loss of power, if that helps. Well, yeah, that does actually. That's two bits of the picture. Now, do I have a compound problem? Do I have an electrical problem? Or is the clonking something to do with something that fell off? Well, basically, mechanical and electrical are two totally different things, unless the electrical is causing a mechanical problem. So I've got a shed load of DTCs from the memory, which is, I'll read them out here. ABS tone sensor, rear right, failed, high speed CAN communication bus, communication loss of power, the powertrain module, invalid data from ECM, coolant temperature circuit, high-speed CAN comms bus, EGR control circuit, range and performance, oil temperature sensor circuit, range and performance, oil deterioration, brake switch AB correlation. So does this tell me anything? Well, yes, it does straight away. So if we look at the 4 here, which is high-speed CAN communication bus, communication loss, a powertrain module, invalid data from ECM, high-speed CAN comms bus. Now this is from the 3 different ECUs that it has on the system, which is instrument panel, the ABS and the engine ECM. This basically is telling me that the CAN, there's an issue with it, it's not communicating. Now this could be a priority problem, or it could be a loose earth somewhere, or the fact that we may have a chafed wire. However, I'm communicating with it, which means the CAN actually has activity, is allowing activity. So this is one thing to keep in mind. But the next set of DTCs, coolant temperature circuit, EGR, range performance circuit, oil temperature circuit, range performance, brake switch, AB correlation. Well, these are all testable. They can either be done with a multimeter, a scope, or from the scanner itself. With live data. Now these are quite easy to do. If, for instance, they don't look like they're coming up to par, or if, for instance, a brake light switch isn't switching on and off, you know that you have a circuit problem. So going back to the Ethos Tech, we have live data. Now, any good scanner that's worth its salt will have live data scanning. Now, I'm not advocating for this. It just happens to be that I have this is my tool. In this particular one, you have 2 groups of data for the engine. So if I click onto one, that will give me live data for a certain group, and click onto the other, it will give me settings for or live data for the other group. Now, I don't know where they are, so I'll have to scroll through them, have a look. For instance, the brake light switch can just switch it on and off. The other one, EGR control, I'll have to do a road test for that. The oil temperature sensor circuit and the coolant temperature, well, all I need to do is actually have a look to see if it's giving me the right temperature. This one here, oil deterioration, is basically telling us that the oil needs to be changed. It's either gone past its service time, or somebody didn't set or reset the service light on the last oil change. This one is mechanical, it can be tested, and this is the one that I went for first, the ABS system, because it's actually the easiest and I can do it rolling the motor. And I highlighted it on the job card as the first job to do, and I suspect because of the grinding noise, first of all, that was the one to do. And the oil deterioration, well, basically I'm saying that, yeah, it needs an oil change, whatever. Okay, this won't really give you clunking noises or electrical problems. So straight away on a road test, well, it wasn't even a road test, I just moved it a little bit, put my foot on the pedal, and I could feel a grinding coming through the brake pedal. And the first thing that initially, yeah, okay, I've got a brake problem on this one. And yeah, feeling through the pedal, I thought it might be, first of all, the pads. So had a look underneath, check the fronts are fine, the rears look very low, so I got the wheels off. It's on the ramp and on stands. You can see the discs are actually quite badly worn. Shock absorber actually was, the bushes were worn on the bottom. That wouldn't cause a grinding noise. There's nothing to indicate that there's metal to metal, because actually the pads are low, but there's still meat on there. So yeah, that's a bit curious there until I actually moved the wheel. Now you can see this half shaft and drive flange are worn, but it's actually, if you just look at this, the wheel bearing's gone. You can see the amount of play there. These Puma axles, they don't have any adjustment. They're either in or they're completely out. Now you can see the movement there. That would knock the ABS sensor out. So that DTC was actually right. And I'll just show you again. If you can see the amount of movement, that's extremely excessive. So it's time to strip down and have a further look. So with the half shaft out, what we have here, we can plainly see that the bearing has been cooked. And there we go, the half shaft is worn in the drive flange. That's a big problem with these 130s anyway. There is a modification for it. I've done a video on it before, but you can see this is plainly screwed. This would have given a bit of clunking, but it wouldn't have burnt the bearing out. So we'll dig a little bit deeper. It's not often that bearings actually burn out these days. There's always a reason for it. And you can see here it's burnt out that much that it's melted the rollers. Here, this is the front bearing, of course. And this is, for me, actually is a lot more work because I've seen this so many times in the past. Not only is the bearing seized up and cooked everything, it's also friction welded itself up. This was locked into place. It took a little bit of trouble to get out. You can see that it's damaged beyond repair. And yeah, this actually, you can see the play here. This is what set the ABS sensor off. Now, to get the bearing race off the stub axle, I've had to use the gas. And what I do is snick through the bearing race so it opens out a little bit more, and I can then knock it off. You can see that I've cut the insert on the Puma axle there. You see there's an insert between the two bearings and slightly cut into the other bearing. Now, this is actually quite hard to do. With the hub off, usually what happens with a cooked bearing is that it will pick up the outer race, and that will spin in the hub. So that's loose as well. So that's one hub. You can't replace bearings once the hub's got like that. And of course, I didn't gas cut the stub axle because I know how to do this. It's quite tricky to do. However, the stub axle I will replace anyway because it's been very hot. Okay, so you can see plainly here, this is still actually really hot. That I didn't cut all the way through, but I cut it enough to give it enough heat to release it, whereas I cut through the insert there, okay, which that'll be a new spacer. Just for interest, I've just cleaned this up so you can see the bearing race has span and it's picked up pieces of metal and melted them, okay, and you can see where it's span in the hub, and it's not only span where it was, but it's also moved about. So that scrap, that's already been stripped, stub axles off, and this is ready to receive new parts. What I have left over here is everything that is useful except for this shaft here. As I said before, this is you do get a modified one-piece half shaft which eliminates this wear and tear. This has always been a problem with Land Rovers. It should have been rectified years ago, but obviously not. So we've got ABS ring, a caliper, okay. Over here we've got replaced the brake discs, the hub, stub axle, wheel bearings, and of course the wheel bearings will need setting up, which is going to be very interesting because it's not straightforward as just setting end float. So we can positively say that one of the DTCs has been found. There's a few more to go through, and I'll show you a trick in the next video with regards to the CAN bus information. While I'm waiting for parts, I can go and test the other components.